Chapter 7 in our Wildy text is called Active, Reactive, and Apparent Power. Now, this is a chapter that sort of takes it up a notch, so to speak, in terms of our understanding of electricity and, in particular, power. Because up to this point, what we have known is that power is measured in watts. It is the product of the current times the voltage. And that's just, basically where we went with it. We remember that there were three forms of a power equation. Power is equal to current times voltage, and power is equal to the voltage squared divided by the resistance, and power is equal to the current squared times the resistance. All of those were equations for power. But what is amazing and takes this whole it's going to take you into a different world that you hadn't thought of before. And I really believe, the more that you learn and understand about electricity, the more interesting it gets. Because, if you think about electricity and tracing current through a complex circuit of parallel and series resistors, and maybe throwing in capacitors and inductors, that is an important part of what we do, and it helps us in understanding how electricity does what it does. But it's only part of the story, and we can only go so far with it. But this chapter is going to show us that, in particular, to power, that the understanding of power is much more useful in understanding how electrical machines work than just voltage and current. So what you're going to find out, and this is not some theoretical abstraction of talking about power. It's a real thing, okay? And so there are actually what we would define as three types of power. There's what we've always known as power, which is active power, and we measured that in watts, and that's what we have talked about. When we talk about power is voltage times current, or power is voltage squared divided by resistance, or power is current squared times resistance. That's what we've dealt with up to this point. Well, we're also going to find out that there's another type of power called reactive power. It's very real. It exists in our power systems. It's transmitted across the power lines. It's received, and it's actually just, it's received and it's sent back and forth across our electrical systems. And then what we're going to see is a type of power that's actually the sum of these two, but it's not like, when we talk about sum of 2 + 2 is 4, right? It's the vector sum of these two. And it's going to open up a whole new sense of understanding for you when you think about power, hopefully. And then, so what we're going to do, we're going to start out and we're going to look at something called instantaneous power, and we'll look at a sinusoidal voltage and a current, and we'll define what instantaneous power is. Then we're going to also go through the particular meaning of active and reactive and apparent. And we're also going to come up with a definition of power factor, which is another very important concept in this world of electricity. And then the useful concept of the power triangle, okay, and how we use that to solve problems. And what we're going to see is that, up to this point, we've maybe in circuit analysis 1 or maybe 2, we went through all these complex circuits and worked through all this stuff. We're going to see that when we encompass all of the concepts here in chapter 7, we can work some incredibly powerful circuits. And they're very easy because instead of focusing on voltage and current, we focus on power. And it's really interesting. I hope you enjoy this. It's a very important chapter.